So first, that definition. So what is a dynamic web application? Well, it's not static, first of all. HTML views are rendered on demand given the state from a database. So it's a full stack application for all the way from the data persistence layer to the presentation layer on the front. If you're building an API, that's a dynamic web application. So it doesn't have to necessarily be HTML, though I'm going to talk a lot about what those views look like. This could easily be a JSON API or an XML API. And frameworks for these types of applications have existed for a long time. I believe last I checked, it was like 80% of the internet runs on WordPress. That is a dynamic web app framework. You'll see others here, Django for Python, Laravel for PHP, personal favorite Express in the Node ecosystem, and Rails. And I actually want to talk a little bit about Rails today. It's where I come from as a background developer. I did a ton of Rails development back in the day. These days, I'm almost exclusively JavaScript, both on the front end and the back end, but we'll use Rails to start talking about the traditional 3-tier architecture. Now, this is going to be pretty familiar to most people as MVC, or Model, View, and Controller. They're a little out of order here, but I think it tracks. Basically, the data layer, the application layer, and this is where we're writing most of our code in these 3-tier architectures. And then, of course, presentation. So that is what the user or the consumer ends up seeing. So in the framework inside Rails, I've gone ahead and annotated these here with those Ruby classes we used. Data was the active record. The controller was an action controller, and the presentation was an action view. This is what I want to call the logical architecture. So how do developers reason about the thing that they're building? Usually we would divide up this in our head, and it made it very easy. And previous talks today even touched on this, that Rails was very approachable. Even if you've never been a part of that business model or that product, you could jump into a repository and understand based on conventions what this thing is doing. Whether you understand the code line by line, this logical architecture gave a set of developers, if you knew the stack, a way to dive right into an application. But it does differ from the Rails physical architecture, at least the Rails physical architecture at scale. So as we started deploying Rails apps, we could quickly realize these things needed to scale horizontally. With all that good traffic we were getting, our Rails applications were starting to fall down. And this is, we can talk about Ruby performance versus Python or whatever, but I think any 3-tier application at a certain scale starts to trip up. So we started to do some smart things, moving our database server out of the appliance that actually runs our Ruby or Python code. We would add on other servers like a cache server to really increase performance. And then we multiplied the number of web servers in our stack to many, many instances, depending on your scale. I think you could probably talk to some Twitter engineers circa 2010 to 2012 on what they think of scaling Rails out as that company grew. Of course, this needed a load balancer to help coordinate all of these resources, making sure that the users on one end were in touch with the instance they were supposed to be talking to, and that all that data was persisted correctly. Of course, we also had a CDN, or content delivery network. This was a really good advent for distributing static assets, things that don't change a lot, certainly not changing on every page load. You can think of CSS, JavaScript, and images. So it did differ from our logical architecture, but as developers, we were really only concerned with that deployment target of those web servers. So the code we were writing every day and likely contained inside a single project in our version control was what was going to those web servers. The rest of it, though connected, was a separate chore. If we needed to tune our load balancer or update the database version, those are separate tasks outside of our project. So In some ways, this was handled by really smart tools. Heroku particularly comes to mind. That was a revelation at the time. And still today, they have an excellent product that's going to try and handle a lot of this for you. But again, it wasn't part of what we were doing day to day, writing code in a Rails infrastructure. So these traditional dynamic apps, and I've already kind of talked about a few of these issues, they had a few problems. Like I said, the logical architecture doesn't necessarily match the things you're physically deploying to. This made deployment kind of a moving target. You were slow rolling out instances, trying to make sure your code was literally distributed around the world to different machines, that it booted up correctly, connected to the database correctly, handled any sort of migrations. And some of those appliances that were attached to our web servers were moving targets. Maybe somebody changed them in the meantime. Maintenance costs was pretty high, and I mean in terms of dollars and developer hours. Scaling out a traditional 3-tier application can get very spendy very fast. Not to mention all of the developer hours sunk into patching and debugging these things. Last, I think background jobs, which are required to make your application as performant as possible, weren't necessarily first class. They often felt bolted on. Our frameworks, I don't want to throw any particular framework under the bus, but several did think about them, but they often weren't attached to the code we were writing in our main Rails project folder, and probably not checked into the same project in version control. So more recently, we've seen other types of tech stacks and architectures emerge. I'm sure most developers in the room know what the Jamstack is. And by the way, I don't want to throw shade at any specific stack. I really enjoy both Rails and Jamstack sites. I've definitely made a living from both. But the ideals of Jamstack kind of flip that 3-tier on its head. It's going to be totally static. We're going to write just a client application that we're going to bundle up, toss it on a CDN, and then ship that to each user's device. So all of that business logic presentation is all part of an immutable deployment, meaning the deployment that's up there is not going to change in itself. Nothing on the file system is going to change until we say that that deployment is void and we're going to send a new one. This approach really empowered front-end developers. And I think about the time this Jamstack idea came out, I was really focused on front-end web development. So it was really empowering for me to essentially outsource my backend. A huge crop of services popped up seemingly overnight to offer you as a developer all sorts of features for your application. So you could add authentication with Auth0. You could swipe a credit card with Stripe. These sort of services to add functionality are still popping up all the time. So going back to that idea of logical architecture, and this is how specifically developers think about the thing they're building. The nice part about Jamstack was all I had to worry about was the client app, the thing that was bundled up, that HTML, CSS, and JavaScript that were, and I would create a single artifact and shoot it up to the cloud, and then it connected to any number of APIs. This is really easy to reason about because for the most part, I'm only writing in one programming language, JavaScript. My markup is HTML or CSS. Excuse me, there goes the voice. But what was this like when we hit the physical architecture? When we actually deploy it into the real world or the cloud, what does that end up looking like? Well, you can see on the left side here, I've sort of exploded that single API into what it actually is, which is any number of services that provide all those features. In the middle is my code that likely has, for each service I plan to talk to, additional code. Luckily, that is all sent from a CDN, so it should be very performant. It's still really easy to reason about this. It's just starting to get a bit complex and maybe even problematic with all the different connections that are outside of our control. So specifically talking about that deployment target and the artifact we own as developers and how it relates to everything else. We really only control that, that client-side application. And this is a good thing for the most part. I mean, it's simple enough to think about, like I said, but these other services are not in our version control or in our control at all. So if one falls down, isn't able to respond, God forbid there's an API shift that no one told us about, it can get a little bit problematic. So Jamstack also has its trade-offs. I think the most important one is that it makes us beholden to our client devices. So that is the things our customers and our users are using, be it their phone or their MacBook or whatever. We're unsure what the performance is like on their device. Also, we're unsure what the JavaScript runtime they're using is. I mean, it's not as bad as back in the day, like I was saying with IE 9 through 6 that I had to support, but it's still not simple. The other one is the network environment. Do they have a good connection? Did one thing drop before another? Is there a race condition in the network? We can't always be sure about that. And another big one, they're not dynamic by default. And what I mean is dynamic being where the initial state of the application is based on live data. A lot of the Jamstack apps that are shipped, they start with no knowledge of where they are or who they are or what's going on. So we need them to boot up on the client, figure out the world around them, and then start running code. So while that complex ecosystem of services and features is an advantage, it can also be a disadvantage because it leads to a lot of tooling and a lot of plugins to sort of wrangle all of this together. It ends up being a lot of stitching and glue code to hold it together. So you may have heard in the area of energy economics, there's something called the rebound effect. I won't read the definition from Wikipedia here, but it boils down to that you don't always get as much out of a system that you would expect given a new technology. So what does that mean? Well, as we start engaging in new technologies that have an expected return of gains, because they are utilized more, we are going to see a diminished amount of return on those gains. So it's essentially a fancier way of the diminishing return rule, or an 80-20 rule. Now, this isn't necessarily one-to-one with web applications. So my colleague at Begin.com, Simon, he came up with and coined the JavaScript rebound effect, where the expected gains from a new JavaScript framework are always less because of the amount of JavaScript being deployed to the client. The additional JavaScript diminishes the beneficial effects of the new technology, and in some cases can actually make things worse. So basically, as you're solving more and more problems with JavaScript, you ship more JavaScript and your gains are diminished from what they would be. Now, that's not to say they're completely negated. It just doesn't lead to that large impact you were hoping for. So this kind of brings up our new idea, functional web app. We call it FWA for short. I'm not sure that's that many less syllables, but it works for us. You can check out our website, fwa.dev. It's sort of a white paper type example website, and I've pulled the definition for FWA here. Functional web app is an architectural pattern for building web applications and APIs. It empowers developers with the flexibility of dynamic full stack applications. So think of those, the Rails apps and the dynamic web apps I was talking about before, paired with the ease of scaling of a static website. So the inherent power of a Jamstack website powered by a CDN and static assets. So it's a whole new approach based on both of those ideas. It's HTML first, so that every response is dynamically rendered with personalized results for the state of that application. This is a huge boon for accessibility as well, because we're shooting down a whole rendered stateful document to the client every single reply. It's Cloud Function centric, so it's many small linked apps working together rather than a larger tangled monolithic one. Cloud Functions is a specific term we've chosen here. I would say in some sense it's synonymous with serverless or microservices, but both of those terms we've seen a little bit of confusion around. So we've kind of settled in the middle ground here for Cloud Function. Importantly, FWAs also have an on-demand database. So it's a full stack application. It needs that database. In our case, since they're on demand and managed, they auto scale. So there's no sockets or connection pooling, plus they're just wicked fast. Last, declarative deployment. So we have explicitly defined our infrastructure as code. You'll see this referenced as IAC. This leads to what we call like the three facets of an FWA: cloud functions, a managed database, and deterministic deployment. So there's no real framework here. It's adhering to these three principles can make your application a functional web app. So going forward, I want to talk a little bit about the logical architecture. We touched on this with Rails and we talked about it with Jamstack. And you'll notice the logical architecture for an FWA is actually pretty similar to a Jamstack in that it's essentially a two-tier application. We have a data access layer for persistence, and we have our view and controller code. Our application logic lives in a cloud function and data in the database. It's really easy to think about and reason about your application this way as you're building. And now I know what you're thinking. You're looking at this single cloud function and it says view and controller code under there. And you're worried, how do I shove all of this code and it's going to be a mess. And you're not wrong. It is a lot of code, but we actually divide it across a dozen or dozens of cloud functions. So that leads into the physical architecture. And there's definitely a departure here from that logical architecture of an FWA. But as you can see, what I've done is I've sort of outlined two groups with a gray box. And the purpose of that is to illustrate that these are hands-off for us, or at least the environments are. I can't shell into the box at Amazon that runs my Lambdas. That's their job. And it's the same with the database. It's somebody else's job to make sure this thing scales out. It has the availability. It's got the security patches. It's ready to go. All I need to do is provide the data and provide the functions. You'll notice that I have many cloud functions here and they respond to different protocols. I realize that font's probably pretty small to see, but one of them says HTTP, another has a WebSocket protocol. I've got scheduled cron jobs. I've got pub/sub event queues. The other part is the client, and we're still using a CDN here. That should probably be in a gray box as well, because in theory, all we're doing is publishing our static files so that they're available to the client that gets responses from our cloud functions. That's part of why I left the HTML file out of the client here, because HTML is being rendered dynamically by the server and sent to the client, whereas our static assets like images and JavaScript are being fetched from a CDN. So let's put those two side by side. On the left, I've got the Jamstack, sort of rearranged it here, and on the right is a rearranged functional web app, looking specifically at the deploy targets. So when I say deploy target, I mean, what is the thing that our code is concerned about? And on the left, it's just that small section of our client. And like I said, this isn't a bad thing. This is actually really simple for a developer, but it does put a lot of things outside of the realm of our control. On the right side with functional web app, because we've declared our entire infrastructure as code, because we've configured that ahead of time, we're going to maintain control of all of those resources, and our cloud provider is going to provision them according to the instructions we give. So in that way, it's a versioned artifact of our code base. So some functional web app superpowers. This is my favorite slide. I think that functional web apps are super powerful. You can build a full stack dynamic web application, batteries included, with this paradigm. And I can personally attest to the developer happiness. Having built web applications in many ways for many platforms, this is way less ceremony and configuration of configuration. I get to just build things and ship them. Last, it's also very accessible. And I mean that from both sides. So it's accessible to a variety of developers, but it also creates a application that is very accessible to end users. So the FWA approach is for developers of any experience level, because you can create cloud functions as simple or as complex as you want. You can create 1 or 147. It's really up to you how you want your application to work. And then, of course, since we're always rendering HTML or valid markup in real time with state attached already, that's going to be more performant over the wire, and it's going to send a fully readable, digestible, SEO optimized view down to the consumer. But I'd be remiss if I didn't mention some drawbacks. So just like the other two approaches, there are definitely drawbacks here. I think the one you're going to hear most common, or at least right off the bat, are cold starts. What's a cold start? A cold start is when a cloud function like a Lambda or a worker or something hasn't been called in a while. So it actually scales down to 0. It's asleep. It needs to boot up. We've found ways to mitigate this, and it's something that both tooling projects and providers, vendors, are working actively to solve. We found that in the worst case, if you're looking at a 1-second cold start, if you keep your function under about 5 megabytes, and you're thinking, wow, if I look at my node modules right now, or my gem folder, it's just huge, the bundle. We find that actually, as you start to break your project into its logical pieces, into its own cloud functions, you'd be surprised how small that code footprint can actually be. The other thing is the database story is still evolving. We have database appliances available from vendors like Dynamo that are super fast and available. But it's always nice to have third-party options. I've seen and had particular interest in a few lately, namely PlanetScale, Fauna, and CockroachDB are looking at that managed database as a service. The next thing I've heard, and I run into this a bit, declarative infrastructure as code can be a barrier to entry. And I agree with this to a point, because it's definitely a new paradigm. Who wants to learn about infrastructure? I mean, that's DevOps job, right? I'm sure there's DevOps people who love that, but it's not for me. But I've made a note here, hold my keyboard. I'm going to show you in a few minutes how you can do it too. Last, and I think this is a big one, and it's definitely a viable concern for organizations building this way. You're looking at potential lock-in as you relinquish control of those machines and those environments to a vendor. It means you were probably stuck with them for a little while. But in our experience, picking a single cloud provider, going all in with that provider, is worth the risk of maybe having to rewrite later if your cloud provider shuts down. When is AWS shutting down? Probably not anytime soon. So I wanted to give a quick glance at what's the ecosystem like right now? What's the tooling like, and who's doing this in the real world? So on the left side, I've got a list of tools, formats, and providers that help build applications this way. Now you can build other types of applications with these same tools, but I mean, these are particularly tuned for functional web apps. At the top is Architect. It's an open source project that deploys to AWS. It's what I work on, but there's something similar called Bicep for Azure. AWS has their own toolings, and I've been particularly excited about things coming out of Netlify and Cloudflare as well. Plus, if you've been keeping up with Deno, they've got a new service called Deno Deploy that's also really exciting. As far as functional web apps in the wild, I think a lot of case studies and a lot of advocates will point to the BBC as a really standout sort of serverless application. I doubt they called it a functional web app when they were building it a few years ago, but they deliver most of their web content this way. You'll notice a few other big brands on the list, but at the bottom there is Begin.com. That's who I work for. We help people deploy an architect application or functional web app without the need for an AWS account. And Begin.com itself is a functional web app, and it runs in this same way. Okay, so let's put a little code on the screen.
This is a short configuration file. It's totally theoretical, but it's written in a format we call ARC. So it's just a .arc file. It's basically a project manifest where I outline the resources I intend to provision for my project. It's a really good little summary of what my application does. So this one is a theoretical blog app. It's pretty easy to read. I've even added a few comments to say, to show how, okay, this static declaration is going to create an S3 bucket. Here are 3 HTTP lambdas that are going to sit behind an API gateway. And finally, I've got a DynamoDB table to store the posts for my blog. So next, I want to get into each one of these sections and types of configuration. I'm actually going to toss out this blog example because I've got a new one for a theoretical functional web app for 200 OK. And we're thinking like 2023 registrations, right? So let's walk through what that would take to build an FWA with Architect. Again, at the top, we've named our project FWA 200 OK. That's going to help AWS form or create a CloudFormation stack. Don't worry if you don't know what that is. I honestly didn't either. It's going to all be created and provisioned for you by Architect. Again, we've set up a static bucket. In this case, we've configured it to use the local public folder assets, and we're going to go ahead and fingerprint those assets, meaning they will we will modify their file name in real time on deployment so that we can easily invalidate the caching later. Next, and this is usually when I jump into an Architect project, this is like the block of code I go to right away. What are the HTTP routes? It reminds me of a Rails routes file. Each route is its own Lambda function, and it's all set up behind an API gateway. So my example here is kind of REST-ish. You can see we can get the index, we can create users, we can let a user update their own user account, we can list events, we can create new events, we can update events, and most importantly, line 15 there, a user can presumably register for an event. Another thing I wanted to point out, on line 14 and 11, you'll notice those colons with those slugs. Those are actually path parts that can be dynamic, so that similar to like a Rails framework, we can pick those up in our Lambda handlers. So the next chunk, and to be clear, this is like the second chunk of the same file. I've tried to keep the line numbers lined up. Pub sub events. So we can declare a set of expected events that might occur throughout our app, and any Lambda can publish an event. In this case, I've called it new registration. So presumably somebody signs up, and that post endpoint is going to publish an event called new registration. Well, our listener function is going to wait for that to happen from a queue, pick up that event, and then act on it. In this case, we might want to do something like charge your credit card, send an email, or even just update our company Slack. Similarly, we can have scheduled jobs. These are things that run in the background at set intervals. So I've created one here called open registration, and it's only going to happen once a year. I'm thinking so that no admin has to get up and open up ticket sales. This thing will do it for us. But we could also do things like every second if we wanted to. Another very important block are the tables. Again, this is a DynamoDB backed schema here that's outlining a users, events, and registrations table. Now, forgive me for my poor information architecture here, but just to show how this works, I wanted to include primary and secondary keys. So they're also called partition or sort keys in Dynamo. This lets us query based on those fields. But DynamoDB is like a document storage engine, so we can really attach whatever arbitrary data we want, our application wants, to things like users and events, etc. So the last chunk of the Architect file, WebSockets. I didn't even know Lambda can handle WebSockets the entire lifecycle. So maybe our 200 OK website needs a live chat feature. This would be a great way to include that and keep functions to handle each one of those events from our clients using WebSockets. Next, database indexes. This is one that's super helpful. DynamoDB can be particularly tricky to query, but creating global secondary indexes, I can easily, for example here, look up users by their email. And the last block is the AWS block. This is actually project-wide, but it can be configured per function. I've specified the runtime to Ruby here because I think it's really cool that Lambdas aren't just JavaScript. You can run Ruby, Go, Java, Python. It's pretty slick. And so with Architect, you could actually make a hybrid app where some of your things are Java, others are Python, and Node for your HTTP Lambdas. I've also made this one unnecessarily large. It's 10 gigabytes. That's a new thing with Lambda. They used to, I think the limit was 500 megs for temporary disk storage, but it's up to 10 gigs now. And the last one is one of my favorites. I can declare the architecture now for a Lambda. So I've picked ARM64 here because one, ARM compute time is actually cheaper and faster. So you pay less and then it's faster. So you pay for less compute to get a better function. It's just a win-win. We've noticed this is really performant with Node 16. So this is like a total of, I think looks like we've hit 50 lines. I think it's about 40 or so of actual code. There it is all on the right side of your screen. Probably hard to read, but the takeaway here is this 41 lines of Arc configuration actually generates over 1,600 lines of CloudFormation. If you're not familiar with AWS and CloudFormation is basically like the assembly language of the Amazon cloud. It tells Amazon, given this giant document of information and configuration, go create a bunch of resources for me. And then I will give you all the code that you need to put into each of those things. So this is pretty amazing because it's so simple just to write my application in this way and know deterministically that it's going to come out, excuse me, the same way for CloudFormation each time, and that Amazon is going to create the exact same infrastructure every time I deploy. A couple more cool features I just want to share real quick. Architect has a CLI that will actually scaffold entire projects for you. So I plugged that 50-line or so Architect file into the CLI, and it generated this folder and file structure you see on the left side. So each folder is going to contain an index file. That index file is my Lambda. So I can just start writing code and then have that deployed to live AWS infrastructure. You'll notice I even added a shared folder. A common worry is copy and pasting logic, maybe data modeling or other sorts of schemas across functions. Well, Architect allows you to share code across functions and automatically handles that hydration for you on deployment. The last and probably one of the coolest things about Architect is that you can locally emulate everything I just showed you in that Architect file. So we can run an instance of DynamoDB, we can create an HTTP server, we can run all those background jobs or invoke those custom events so that our pub sub all works locally and we can test it out completely before even deploying to a staging environment. Now, all these cool things I've said about Arc are not just unique to Arc. A lot of other frameworks do this, and they deploy to other things other than AWS. So I encourage you to kind of check out the landscape, see what you like best. And if you'd like to give Arc a try, definitely do so. But if you want, and you don't want to deal with getting, your keys from AWS and setting up all of that, you can actually go to begin.com and try out deploying an Architect app totally free right now. So yeah, that's it for me. I would say go forth and functional web app